Welcome back to Operating Systems Crashcast. I'm Victor, and today we're diving into Section 4.5, Implicit Threading. Sheila, are you ready to unravel this exciting topic?
Absolutely, Victor. I'm really looking forward to this one. Implicit threading is a fascinating approach to concurrent programming that's become increasingly important in modern operating systems.
Great. Let's start with the basics. Sheila, could you give our listeners a quick definition of implicit threading?
Certainly, Victor. Implicit threading is an approach where the details of thread creation and management are abstracted away from the programmer. Instead of explicitly creating and managing threads, the programmer focuses on identifying parallel sections of code, and the underlying system or library takes care of the threading details.
That's a great explanation, Sheila. It's like the system is doing the heavy lifting of thread management for us. Now, one of the key concepts in implicit threading is the idea of thread pools. Can you elaborate on that?
Of course. A thread pool is a collection of pre-created, reusable threads that are ready to perform tasks. Think of it like a restaurant kitchen. Instead of hiring a new chef every time an order comes in, you have a team of chefs ready to cook. When a task comes in, it's assigned to an available thread from the pool, rather than creating a new thread each time.
That's a fantastic analogy, Sheila. It really helps visualize the concept. Now let's talk about some specific implementations of implicit threading. One popular option is OpenMP. What can you tell us about that?
OpenMP, which stands for Open Multiprocessing, is a set of compiler directives and library routines for parallel programming. It's widely used in scientific and technical computing. With OpenMP, you can simply add special instructions to your code to indicate which sections should be parallelized, and the OpenMP runtime takes care of creating and managing the threads.
That sounds really user-friendly. Another implementation I've heard of is Grand Central Dispatch, or GCD. How does that compare to OpenMP?
Grand Central Dispatch, developed by Apple, takes a slightly different approach. It uses the concept of dispatch queues. You submit blocks of code to these queues, and GCD manages the thread pool to execute these blocks concurrently. It's particularly well integrated with Apple's ecosystem and is designed to work well with event-driven programming models.
Interesting. And there's one more implementation I think we should mention. Intel's Threading Building Blocks, or TBB. What makes this one unique?
Intel TBB is a C++ template library that abstracts away the low-level details of threads. It provides high-level constructs for expressing parallelism in applications. TBB focuses on task parallelism rather than data parallelism, which can be more flexible for certain types of problems. It's designed to scale well on multi-core processors, which is crucial in today's computing landscape.
Thanks for breaking that down, Sheila. Now, implicit threading sounds great, but I'm sure there are pros and cons. Can you share some of the advantages and potential drawbacks?
Absolutely, Victor. The main advantage of implicit threading is that it simplifies concurrent programming. It allows developers to focus on the logic of parallelism rather than the nitty-gritty details of thread management. This can lead to cleaner, more maintainable code and can help prevent common threading errors like deadlocks or race conditions. However, there are some downsides. The abstraction can sometimes lead to less control over thread behavior, which might be an issue for performance-critical applications. Also, implicit threading might introduce some overhead compared to carefully optimized explicit threading.
Those are great points, Sheila. It's clear that while implicit threading can be a powerful tool, it's not a one-size-fits-all solution. Before we wrap up, could you give us a quick overview of when implicit threading became popular and why it's relevant today?
Certainly. Implicit threading gained traction in the early 2000s as multi-core processors became more common. The need to leverage these multiple cores efficiently, coupled with the challenges of explicit threading, drove the development of implicit threading techniques. Today, it's more relevant than ever. With the proliferation of multi-core and many-core systems, from smartphones to supercomputers, the ability to easily write concurrent programs is crucial. Implicit threading allows developers to take advantage of parallel hardware without needing to become experts in low-level thread management.
Thank you, Sheila. That really puts things in perspective. To recap, we've covered implicit threading, which abstracts away the details of thread management. We discussed thread pools and looked at implementations like OpenMP, Grand Central Dispatch, and Intel threading building blocks. We also considered the pros and cons of this approach. Any final thoughts for our listeners who might be preparing for interviews on this topic?
I'd say the key takeaways are understanding what implicit threading is, how it differs from explicit threading, and being familiar with common implementations. Also, be prepared to discuss the trade-offs between simplicity and control when it comes to threading approaches.
Excellent advice, Sheila. That wraps up our discussion on implicit threading. Thanks to all our listeners for tuning in to Operating Systems Crashcast. Until next time, keep those processors busy.